Alrighty, folks. Today we are going to be talking about current, voltage, and resistance. So, really quickly, if you have not yet, please have the PhET circuits simulation open during this lesson. In addition, if at all possible, I highly recommend that you have the Nearpod open as well. If not, you'll be able to follow along on the Nearpod afterwards or check out any videos included in the Schoology folder. All right, let's go ahead and start with notes setup. Today, your essential question is, what is the relationship between voltage, current, and resistance? Your three guiding questions for today are, what is current, what is resistance, and what is voltage? Go ahead and pause the video, set your notes up, and then restart the video. All right, our learning target for today is I can use Ohm's law to show how voltage, current, and resistance are related. All right, so we're starting off here with this simulation from PhET, and I want you to just go ahead and pause the video and kind of mess around with this simulation and see what you notice. Go ahead and pause. All right, so what you should be able to see is on this, you can go ahead and slide this, which changes the voltage. Then you can slide this, which changes the resistance. And it makes super cool noises. So what I want you to notice here is that there are a couple of things. First off, voltage is represented by V and resistance is represented by R. The more voltage you have, the bigger the V. The more and less resistance you have, the bigger and smaller the R. Now we have another thing here, I. I is current, which we'll be talking about later, but you can see that the I changes as well. So let's go ahead and see what happens. If we adjust the voltage, we can see that the number of batteries changes. So if you increase the voltage, you have more batteries. If you decrease the voltage, you have fewer batteries. In addition, as the voltage increases, the I gets bigger, which is also represented by these red arrows here. They get bigger as the voltage increases. Resistance, if I decrease the resistance, you'll notice that that causes the current to get bigger. And if I increase the resistance, the current gets smaller. The other thing that changes is when I change the resistance, the number of black dots in here changes. More current, more black dots, less current, or sorry, more resistance, more black dots, less resistance, less black dots. And those black dots basically represent blocking electrons from flowing through. Alrighty, next up here. Let's start with current. Current is the flow of electric charge, and it is measured in amperes. Electric charge that moves between two places, such as the terminals of a battery. The other day, we were messing around with different circuits, and we saw that when we closed a circuit, as exampled here, we could cause a light bulb to light up. This is because the wires connected the two terminals of the battery, and electrons were able to flow, thus creating current. When you disrupted the circuit and created an open circuit, the current was no longer able, or the electrons were no longer able to flow, and therefore there was no current. All right, so here's what we're going to do. In the PhET simulation, what I'd like you to do is I'd like you to start off by building a simple closed circuit that includes a light and an ammeter. So I have an example of it right here on your Nearpod. I'll go ahead and open up and you should be able to see this is what I want you to have. You'll see kind of it's lit up here. And then the ammeter is right here, so go ahead and grab that. And what you can do is you take this little part right here, and if you put it onto the circuit, it'll tell you what the current of the circuit is. So this is basically how I want you to have it set up for now. All right, what I'd like you to do is change the resistance. How do you change the resistance? And what I want you to try to do here is make the current go down on the ammeter. Go ahead and pause the video and try to change the resistance of your circuit and start it back up. All right, so what you should see here in order to change it is if we go ahead and we break apart our circuit there and we add a second light bulb to our circuit, you'll see that the current goes down. So that is one way that we can cause the current to decrease or increase the resistance by adding another light bulb. A second thing you could do is you could add a resistor. So if I put a resistor here and I check my current, you'll also see that the current went down to 0.45. So the resistor is another way to decrease the current or increase resistance. So resistance is the difficulty of passing an electric current through a material. It depends on the material's thickness, the length, and the temperature. So, for example, your body, when dry, has a resistance of 100,000 ohms. So it's a very high resistance. That's why if you get shocked or you touch like a battery or something, it doesn't tend to shock you. But when your body is wet, your body's resistance goes way, way, way down because it conducts electricity better. And so then if you were to touch a battery or some kind of something with current in it, you'll get shocked or hurt. And so that is different ways that you can think about resistance. And there's a bunch of other ways about the materials that you use that vary the resistance, but that's a good way to think about it. And then the more material you have, so for example, we added that extra light bulb into our circuit, and so that meant that there was more in the circuit and therefore a higher resistance. So when we measure resistance, we use the unit ohms, which is represented by the Greek letter omega. And just so you know, we'll be doing some work on quick quizzes coming up here with this. And unfortunately, you can't really use omega. So if you want to abbreviate for omega on Schoology, you will just use the letter O. All right. Welcome back. We're going to go ahead now and we're going to go back to our circuit. And this time we're going to look at, you can ignore this part about a parallel circuit, but we're going to just go back to our circuit that we had. And instead of using a ammeter, we're going to use a voltmeter in order to measure the voltage. So if you go to the circuit that we had before, I'm going to go ahead and get rid of that resistor and just connect my wire back to here. And I'm going to bring out my voltmeter. So just put the ammeter over to the side. And with the voltmeter, all you need to do is take the two electrodes here and touch them to any two parts of the circuit, and it will tell you what the voltage of the circuit is. So in this example, we have 9 volts in our circuit. So this is where you should be. Go ahead and make sure you have that all set up. All right, now here's what I want you to do. I want you to figure out how can you change the voltage. Now this one can be a little bit tricky. I want you to think about the source of the voltage from the demonstration that we did earlier. So go ahead and pause the video and try to change the voltage of the circuit. Alrighty, so here's how you would go about changing the voltage of the circuit. So if you go ahead and take the circuit apart here, and if we go ahead and just add another battery and connect it back down here, number one, you'll notice that the light gets much brighter, but then if I measure the voltage of my circuit, it is now reading 18 volts. So we significantly increased the voltage of this circuit by adding a second battery to the circuit. And that is because batteries are what produce voltage. And if you have more of them, you produce more push that moves the electrons through. You can also, in this demonstration, go through here and you can actually change the voltage on an individual battery. So if you went about doing it that way too, that's fine as well. Very similar process to what we did by adding a second battery. Alrighty, so voltage, this is the push which moves electrons through the circuit, and it is caused by the difference in electric potential. So you can just think of that as we have positive terminals and negative terminals on a battery, and so the electrons get pushed between the two terminals. That's about as far as we're going to go on voltage in terms of what it is. You just need to remember that it is that push. The metric unit for voltage is volts, or V for short. All right. So before the FET simulate, or we're going to go back to the FET simulation from earlier, and I want you to kind of mess around with it a little bit more, knowing what you know now about current, voltage, and resistance. And I want you to think about what do you notice, and my hint for you is look at the numbers. Go ahead and use the simulation on your own. You can pause this video and then come back and we'll look at it. All right, so what we are noticing here is that if you increase the voltage, that causes the current to increase, but the resistance is not affected by changing the voltage. On the other hand, if we change the resistance, increasing resistance causes the current to decrease. You can see the number went down here. However, decreasing resistance causes the current to increase. And so whereas voltage and current are directly related, resistance and current are inversely related. The more resistance there is, the less current. The less resistance there is, the more current. All right. Go ahead and take a 4-question quiz to see what kind of questions are going to be on tomorrow's quick quiz. Pause the video now, and then I will go through the answers with you. All right, as you increase the voltage, current increases. As you increase the resistance, the current decreases. Which of the following would have a higher resistance? Well, if it is going, or an insulator would have a higher resistance because it is going to prevent electricity and therefore less current is going to flow through it. So an insulator has a higher resistance. The push that moves electrons between different electric potentials, i.e. terminals of a battery, that is our voltage. So if you answered all of that way, you should have gotten a perfect score.